So yeah, I'm Brandon Wilkie. On the team at development team here at 21CS, and pretty excited to be showing some of what we've been working on the last several months here that we're going to have in the 6.1 release of TDMF. So I'll just hop into it. There's um, a few various phases involved in performing large-scale DASD migrations, and each of those, as we kind of saw in the feedback there, kind of presents its own challenges. Some people like things some aspects of that more than others, but a lot of these have a few things in common that make them maybe not that enjoyable. So one, they're really cumbersome and takes a lot of time to collect detailed information that you need to be able to perform a migration accurately. They're all pretty manual, so there's not, in a lot of cases, a set in stone documented process for consistently, reliably conducting and getting through all these different phases. And kind of lastly, that combination of being difficult to do and not having a reliable and having a manual type of process, it's not a great formula for accuracy. And obviously, it's extremely important with something like a DASD migration to perform with complete and total accuracy. So what I'll be showing here will be a walkthrough of one of the key enhancements in our 6.1 release. We've got some other things as well, but this is one that we're excited to show off as the migration planning assistant. And that's a solution that we're going to be, again, delivering in 6.1, and 6.1 is going to be GA tomorrow. So the migration planning assistant is really intended to make it easier to set up and execute large scale migration projects. So um, we've added a lot of different components that kind of assist with that. We've also added some improvements for monitoring and reporting for the migration projects as well, to be able to collect information about success or failure of a project quickly, analyze that, make decisions, that kind of thing. The planning assistant takes a lot of the legwork out of setting up migration projects. So we provide in 6.1 the mechanism that you need to collect information about your system and storage environment. We have a few options that you give us to tell us how you would like to configure, what your preferences for handling specific aspects of your migration project. And then we will analyze your storage environment alongside your preferences to help construct your TDMF migrations for you. I say help completely construct your TDMF migrations for you. So there's also a number of new monitoring and reporting facilities that we've added in 6.1, as I mentioned, show a few of those. Since we're on a kind of a compressed timeline, there's not time to do a fully live demo and explain everything. So the tact I'm going to take here is to review a completed planning environment and kind of go through what the process that was involved in building it and explaining, illustrate as we go along. Okay, should be seeing my screen now. So this is a GTD plan that is shipped in the 6.1 SAMP lib, and this is really all that you will see for the most part that is related to the planning environments for 6.1. So this is the thing that kicks off the entire planning process. This first step allocates a set of data sets for the planning environment, and it will populate the first of those with the set of jobs to execute. So you just provide a couple of parameters to this. One is the high-level qualifier of your TDMF installation. The second is the high-level qualifier you'd like to use for your planning data sets. Optionally, you can provide allocation options for where you would like those data sets to be allocated. And you can also customize your job card if you need to. We have templates. We use a templating process throughout all of the migration and planning. Similar to this, there's separate members for different types of templates that you'll see later, but they all use this kind of construct of having bracket $sign variable name for, as you see here, for job and sysaf that variable substitutions will apply to throughout. So after you run this job, you'll get a set of data sets allocated matching that planning high-level qualifier that you specified. So we see a control data set, and that is going to be where all of the jobs are built at this up to this point for executing the planning steps. There's a discovery database that will contain information about your system and storage environment. A Gen JCL, which is generated JCL that's built by the automation planning facility, a series of reports, and a retry data set that gets populated if any of your migrations fail to migrate any volumes. Jobs will end up in there that will allow you to retry failed volumes automatically. So let's go ahead and look at the control data set. That's where the only one that's really got anything in it at this point in time. We can look at the index member first off, and that gives an explanation of everything that I'm about to describe here. But you'll see a bunch of $ members and a bunch of members that start with this pound sign. And so the $ are largely templates. We have the job card, the job card, and all the template members. So again, we can look at one of these for, say, the TDMF master template, and all of these things are getting highlighted pink, or variables that are automatically substituted or filled in by the migration. If you want to change any of the runtime options, those are listed here. You can set those according to how you would like for your migration. Um, so um, in addition to all of those template things, we have the numbered members here, 1 through 6. So these are in order, of course, of how you need to execute these to set up your migration. So 1 is going to be a discovery program. So as I mentioned, you might do things like decollect. You might have ways to analyze your storage environment. This is a built-in program that's shipped in TMF 6.1 that will do the system storage analysis for you and populate this in this discovery database. So there's not a ton to setting this up, but the key thing that you're going to be doing here is updating these include statements. So you're going to say which volumes you would like to migrate, which ones will be source volumes, which ones will be target volumes. There's a big section up at the top of this that I just scrolled past that in comment sections that tell you the syntax for setting these things up. You can do it by a device number. You can do it by a control unit ID. You can do it by vol, SEER, store group, capacity. There's a lot of options for setting these up, and you can combine, include, exclude rules to get precisely what you want. So, yeah, you run this. This is going to end up doing just a very easy migration or identifying 16 source volumes here, matching 4 Baker 4, and then target units matching Able Baker 4. So let's look at what gets produced whenever we run that. That's going to end up populating the discovery database with a member that is the name of the sysplex that would execute it on. So this discovery tool only needs to be run once per sysplex. It will discover information about everything on all systems on the sysplex. So if you have a multiplex migration, you would need to run it on other plexes. But if you're doing a single plex migration, just one is sufficient. So what we get here is really boils down to 2 sections: a system environment section and a storage section, which is about all of your DASD. So and if I kind of whittle this down a little bit, you can see that what actually gets built here, these are the devices that we had in our include decks. Include rules for source and target volumes. We have in this column 75 is labeled T for TDMF type. S's are source volumes, T are target volumes. So that tells us what you specified on that. I'm going to go back now to the control data set. The next steps 2 through 5 are completely optional steps. So this is for initiating or initializing your target volumes if you haven't already done so. So once that discovery job is run, we know which volumes are your target volumes. We can then help you build the jobs necessary to vary those volumes on, create init statements for the, or sorry, vary this volumes off, generate the init statements for them, and vary them back on. If you want to do this process, you run this #02 gen init, which is going to populate all the members that these next three jobs would use. Look at what that looks like, but this really can more or less be submitted as is. You can, if you want to work with a subset of target volumes, you can apply additional filters here as well. Um, Sorry, I got the wrong member there. This is your this is the job you need. So you got the plan high level qualifier and just the init template and the vary template that you would like to use for generating these statements. And then that would then in turn populate the commands, the member, the TGTV off that would be residing in your gen control after you run that job. That will have all of your vary commands, similar for very on as it is for very off. And then an init job here that's an ICK-DSF job that's going to use as part of the sysindec a target init member in gen control. All right. So the final step here is kind of the meat of all of this. This is the TDMF job generation part. So there are a handful of options here. And again, this is maybe the most tricky part to educate yourself on and learn how to set up and get the migration set up how you want. I can assure you, though, that it is a lot easier than analyzing, potentially thousands of volumes, determining which systems are path to, which systems are online to, where you need to run TDMF masters agents, build out dozens of, TDMF job decks and migrate statement lists and source to target volume. This is going to be way easier than that. So, you have the same two settings here for product high level qualifier, plan high level qualifier. You can tell us if it is a replicate or a migrate statement. You can tell us how you would like to perform your mapping. So we have a few options for how you can do source to target volume mapping. One of them is explicit, which is used here. And that implies that you're going to have an additional source to target DD that has device number mappings here. So this is what we have. We're going to go from 4Baker4 asterisk to AbleBaker4 asterisk, and that's going to be our explicit mapping. You can also do auto mapping, which will do automatically do capacity matching, source to target volumes. There's also additional rules for allowing small to large. You want to migrate or allow migration to larger capacity target devices. Otherwise, it does verification around that and won't do automatic mapping from a small to a larger device. There's also options here for handling special migration, special volumes and duplicate volumes. So there's going to be a handful of volumes that you can't migrate without a little bit of extra handling in a typical TDMF migration. So there's going to be different options for how you would like to deal with those volumes. The default is to just list the volumes out. So those volumes get kind of paired out into a separate list, and you can handle those if you would like later. There's options for performing online and offline migrations of these as well. If you plan on migrating those on a system while you have a production outage, you can do an offline migration to migrate those from a control system, for instance. The last couple options here have to do with our TDMF syscom datasets. So you specify a mask for your volumes that you want to use for your TDMF syscom volumes. We recommend that those be dedicated volumes and you only have one syscom per volume. So you want to make sure that you would have the sufficient number of volumes available for that purpose, and you give a prefix for the dataset qualifier to use for those syscom datasets whenever we allocate them. So the last kind of thing to note here is that we're not doing anything here other than generating JCL. So there's nothing going to happen to any of your storage devices, any of that. At this point, we're just setting up jobs. You can play with this until you feel comfortable with, get a better handle on how the different options affect the output and until you get a handle on it. So no risk, nothing to be afraid of. So, but yeah, I'll pop back now into what gets actually built out into the gen control. So remember, we're working with 16 volumes. We specified, I did not show that, but we had a volume limit of 4, which means that we're going to only allow up to 4 volumes in to each master. So one of the typical methods for setting up large scale migrations is to spread those out across multiple masters. There's a number of reasons why that's preferable. Uh, and so this allows you to kind of limit the number of volumes and in a migration if you would like to, in a session, if you would like to set it up that way. So we're going to end up getting easy math for 4 sets of 4 sessions with 4 volumes in each one. And actually, before we even look at what got generated, I'll swap over real quick and look at the output from running the gen JCL. So you'll see just a series of messages. First, every time it runs, it will save your previous run into the .prev data set. So your gen control will save the previous version in case you'd like to compare to the prior run. All these members are getting written out to the gen control data set. And then you get a nice little summary here, a breakdown of what it built out based on your preferences here and your settings. So we see 4 different migration sets, 4 different sessions. See the master job that was generated for each one. There's also a dedicated scan member. So if you want to run a TMF scan, again, all of these things have templates. So if you want to affect the way that these get generated, you can do that by editing the templates there in the control data set. This also tells you which job these are intended to run on. So you can see our master here on this first job's going to run on system TDMA. All the agents are going to be running on the other 3 systems in the sysplex, TDM1, 2, and B. And you'll see that these are going to get spread out over all members of the sysplex. So your master here is on A, your master here is on B, 1, 2. So there's a lot that goes into this, to deciding all of this, that the TMF gen or the GT gen job is walking through. But it does, the key point here is it takes a lot of the guesswork, the manual, laborious part of going through and analyzing your storage environment and doing all the mapping. It takes all that out of the equation and performs the bulk of that for you. So now let's pop into the output from the GTD gen job is going to be in the gen.control data set. So this thing was empty prior to running that. Now it's completely populated. We see here we have a few members that have an @ sign prefix. We have some agent jobs that got generated. We have list members that got generated. We have masters and scan. So anybody that's familiar with TDMF knows that you have the master job, you have agent jobs, and you have the option to add a scan option to the master. Again, we broke that out from the main master job so that you can submit scan jobs before running a real migration, check for any configuration issues, that type of thing. But you could submit scans and agents separately before you run the masters and agents. But the lists are referenced by the master, and they just have your list of migrated or replicate statements in here. So this all gets built out, adds a few comments as far as which mapping rule, source to target mapping rule got applied. If there's comments on your source to target mapping rule, it has a comment section for source to target unit over here, and this is the number of allocated cylinders on those volumes. And you get a nice little total line here on each list as well. So let's see. So other jobs up here, you have, first off, you have the syscom allocation job. So this takes those 2 options that I mentioned in the GTD gen, but for your high level qualifier, for your syscom, and your volumes, and it builds out intelligently. Again, it sizes these according to the size of the migration, the number of agents, number of volumes that are in each session, and allocates them appropriately. There's a job to catalog all your planning data sets to generate a CAMS define job. And so if you're doing a multiplex migration, you can use that to quickly generate the statements you would need to catalog all these planning data sets on another sysplex. Um, And let's see, we have a monitor job here. So this is something that you can run while the migration is running to help automatically report. It will check there's two intervals involved here. One is how frequently it's going to run. Two is how frequently it's going to report. These are in minutes. So this is set right now to run every minute and send a report every 3 minutes. It's probably a little aggressive, but it was just for testing. And then optionally, you can specify the job that you want to submit every report interval. So this would run every 3 minutes. It would generate reports and submit this job. The reports are going to be written out to there's a text version, HTML version, equivalent content, but these are going to be written out to these data set here. And where we see the job to submit portion of this working is that you could set up a job to, for instance, send an email, send some type of notification about how this is progressing, and include the one of the reports. So this is an example of the HTML formatted report getting sent via email. We don't provide any email facilities in 6.1, but if you have an existing email program, you could set it up to run like this. This shows every time it runs, it's going to show a history of the prior run and the current run at the top, previous runs below, uh, totals for each session, totals for all sessions, and then a breakdown of individual sessions and what phase they're in. So these were all in refresh. They'd all completed copy at the time this ran. If there were still volumes that were in copy, it would break all these out and nice little summary type format. So um and kind of the last thing I wanted to mention was the global controller here. So we have a new concept here that will allow you to group multiple TMF sessions, master sessions together, and that's here. And you can, if you have this parm maps to a parm that you put in each master, and that all works nicely. And finally, we have a series of reports that get generated after the fact, a combined report that you can run a job to build this out that gives you a full summary of um, all of the individual runs, message reports for each individual session that runs, and a volume summary report that verifies your migration. So ran out of time there, tried a lot to squeeze in, but I need to go ahead and move on here. Um, so finally, that was there's a lot to cover for the migration planning assistant. There's a lot more I couldn't get to, but we also have some other enhancements in 6.1 that are very nice to use. A few of those are mentioned here. But yeah, if you would like any information, more information about the migration planning assistant, more information about anything in 6.1, we would be glad to answer any of those questions. Just let us know.